Hi guys, it's Harvey from All Parts Pool and Spa. Today I got a very good email. He said, Harvey, it's nice that you teach me a little bit about Stay Right. And don't forget about my pool and spa talk, which I'm going to be opening. And I like questions like this, but we're going to start it. This is a diagram of a millivolt on a Hayward millivolt heater. The reason why I start with millivolt heaters, if you understand what a millivolt heater is trying to do and understand the safety loop, you can start diagnosing the big fancy heaters. Because if you have power, argument's sake, let's get off track. Say argument's sake, we are checking power on a fancy Hayward heater and we think it's the igniter. We got voltage at the igniter, but we don't know if it's glowing. Well, if we have an amp probe, we got voltage there and we got amperage, you know it's glowing. All right? I'm getting ahead of myself. Let's back up and start teaching you guys on millivolt heaters. This generator is where the pilot light sits and burns and creates power to this gas valve, all right, through this loop, okay? Once you complete the circuit of voltage or milliamps voltage, it goes ahead and tells this gas valve to turn on. So if you got your pilot light on, more than likely the generator is working because the pilot light is on. It's telling this gas valve that we got the correct milliamperage voltage, all right, to this gas valve to stay on. That's one big important thing. If you are trying to light this and you push it and it keeps going out, you have a problem with your generator where the pilot assembly is dirty and it's not giving enough heat for this generator to generate power for this gas valve. All right? So let's make this clear. If we got the generator and the pilot light stays lit, you are sending a signal to this gas valve. Now all it is a simple safety loop. This is a very simple little diagram, okay? But anyway, sorry about that little interruption there. You'll probably get more. Anyway, you have your thermostat. And I'm going to make part 2 because this is going to be very long. You got your thermostat. Basically, your thermostat is an on and off switch. You turn it all the way up, you ohm it out, and you should have a dead short. The meter should beep or read all zeros. Your switch is the same thing. Turn it on, put the ohm meter to these two. You should have a dead short. There's a terminal block on the jumper. This is for if you have a remote control, you know, a Hayward or whatever. Sorry about that, guys. I tell you it's going to be numerous of them. But anyway, that jumper is really if you have a control system. You have a high limit switch that should be always normally closed. So if you put your ohm meter here, you should read zeros. The limit switch should always be closed. Pressure switch is either open or a closed switch. If you don't have proper water flow or back pressure, this switch will stay open. And then you got your temperature switch and your other switches. So all it is, if you go through this diagram, You can say, well, if I put a jumper from point A to point B, we're just reading this diagram, I can jumper it out and make sure it's a safety loop. I know we've been out in the field, and I know that we can jumper stuff out. I strongly suggest you never jump out a safety system. A safety system is here for a reason. If we have a bad whatever, you do never want to jump out a safety system, ever. If you know you have proper water flow, and I've done it before, and I know I shouldn't, I tell you never to jump out a safety system. It's a bad idea, but it's 3 o'clock in the afternoon and you just want to see if it'll fire. I know I got proper water flow and everything's fine and I don't have a gas leak. Sometimes I jump it out for a second just to see if it fires up. That's it. Because you got other things, dry firing, and just, and I'm not going to explain to you how to jumper it out. That's why you need to understand how a safety system works. It goes from part A to part B. That's it. On a millivolt system. All it is one big loop. It goes from block to block to block to block to block on this millivolt system. So if everything is correct, if you pull off this wire right here, you pull off that wire right here, and we trace back through our safety loop, and we pull off this wire right there. We have the 2 wires in our hands, and we got everything on. We put our ohm meter on these 2 wires. We should show a dead short. If the meter doesn't beep or read zeros, we have either a bad pressure switch or a dirty connection. It's not calling for heat. It's in the safety loop. All right. So make sure you have a meter and you have an ohm meter. But we will start with a millivolt system. It's going to be part 2 on the millivolt system because this is a real bad picture. They assume everybody's expert, so we're not. All right. So a millivolt system, a safety loop, is just one big continuous wire. All right. It's just broken at certain areas. So if you have water going through and you put your ohms meter on here and you don't have continuity through these 2 tabs, you got bad pressure switch. If you put it to these 2 tabs on the high limit switch or low limit switch and you don't have continuity through those 2, you got a bad switch. That's where you need to start. So once you start getting better, you'll learn to pull these 2 wires off, put your ohm meter on through these 2 wires, and you'll find out that you don't have continuity all the way through. So you start troubleshooting. You go into your switches, you go to your high limits, you go to your pressure switches, and the main thing, everything might be good, but corrosion gets to you. A millivolt system really don't supply power, so it can't push power. It has to be absolutely clean and precise for a millivolt system to work. All right, this is class 1 on millivolt heaters. I am going to start training on diagnosing bigger heaters, but we start with millivolt. Make sure you have a meter. Make sure you have an amp probe meter. If you don't, I sell an excellent one on my website. I have a friend named Pam. I bought her a clamp-on meter. I spent $400 for her. Sorriest thing I did. I should have went and got my own meter off my own website. But she wanted a fluke. So, anyway, she got a fluke. Hi, Pam. Love you. Hate you. But anyway, she's a good gal, guys. Anyway, this is part 1. Read and understand your manuals. Get to know your safety loops. Never bypass a safety loop. I can't express it enough. Never, ever bypass a safety loop. Okay, guys, take care.